The world of quantum mechanics is strange and fascinating. It's a realm where the familiar rules of physics break down, and the unexpected becomes the norm. In this microscopic domain, energy, momentum, and other physical quantities are no longer continuous but rather discrete. Instead, they become quantized, meaning they can only exist in specific, discrete values, much like steps on a staircase. Imagine a staircase where you can only step on certain steps, never in between. This is the essence of quantization. That's what it's like in the quantum world, a place where our everyday intuitions no longer apply. One of the most bizarre aspects of quantum mechanics is the idea that particles don't have definite properties until they are measured. Before measurement, they exist in a blurry cloud of possibilities, a superposition of states, where they can be in multiple places at once. Imagine a coin spinning in the air, neither heads nor tails until it lands. This is a simple analogy for superposition. That's the essence of superposition, where outcomes are not determined until observed. This inherent uncertainty is not due to a lack of knowledge or measurement precision. It's a fundamental property of the quantum world, deeply embedded in its very nature. It's as if the universe itself doesn't know the outcome of a measurement until it happens, keeping all possibilities open. This strange and counterintuitive world, governed by probabilities and uncertainties, sets the stage for the even stranger phenomenon of quantum entanglement, where particles become interconnected in ways that defy classical understanding. Quantum entanglement is one of the most baffling phenomena in quantum mechanics. It occurs when two or more particles become linked in such a way that their quantum states become interdependent. They share a fate, even when separated by vast distances, spanning galaxies or even the entire universe. Imagine two coins flipping in unison, always landing on the same side no matter how far apart they are. This synchronization defies our everyday experiences. That's the essence of entanglement. It's a mysterious connection that transcends physical space. When entangled particles are measured, their fates are intertwined in a way that seems almost magical. Measuring the state of one particle instantaneously determines the state of the other, no matter the distance between them. This instantaneous effect is what puzzles scientists. This spooky action at a distance, as Einstein famously called it, seems to defy the laws of physics as we know them. It challenges our understanding of the universe. The strangeness arises because information seems to be transmitted between the entangled particles faster than the speed of light, violating the cosmic speed limit set by Einstein's theory of relativity. This apparent violation has led to many debates and further research. This has profound implications for our understanding of space, time, and the nature of reality itself. It forces us to rethink the very fabric of the cosmos. Entanglement is not just a theoretical curiosity, it's a real phenomenon that has been experimentally verified countless times, providing a solid foundation for new scientific advancements. It's the foundation for emerging technologies like quantum computing and quantum cryptography, which promise to revolutionize our world. To grasp the essence of entanglement, we must first delve into another perplexing aspect of quantum mechanics: wave-particle duality. This concept suggests that particles, like electrons or photons, can exhibit both wave-like and particle-like behavior. Imagine a wave rippling through water yet somehow also behaving like a tiny localized droplet. The famous double-slit experiment beautifully illustrates this duality. In this experiment, particles are fired at a barrier with two slits. Instead of passing through one slit or the other like tiny marbles, they create an interference pattern on a screen behind the barrier, as if they were waves interfering with each other. This wave-like behavior is not limited to single particles. Entangled particles, even when separated, exhibit a collective wave-like nature. It's as if they are somehow connected by an invisible wave, influencing each other's behavior across space and time. In 1935, Albert Einstein, along with Boris Podolsky and Nathan Rosen, proposed a thought experiment to challenge the completeness of quantum mechanics. This thought experiment, known as the EPR paradox, aimed to show that quantum mechanics was missing something. The paradox involved two entangled particles flying apart in opposite directions. According to quantum mechanics, measuring the momentum of one particle would instantaneously determine the momentum of the other, even though they were too far apart for any signal to travel between them. Einstein found this spooky action at a distance absurd. Decades later, physicist John Bell devised a way to test the EPR paradox experimentally. Bell's theorem and subsequent experiments showed that the predictions of quantum mechanics were correct. entangled particles do indeed influence each other instantaneously, regardless of distance. This groundbreaking discovery shook the foundations of physics and confirmed the reality of this spooky action. Linked fates entanglement analogies for the perplexed. Entanglement is a difficult concept to grasp. It's unlike anything we experience in our everyday lives. However, analogies can help us visualize this perplexing phenomenon. Imagine two gloves, one right-handed and one left-handed, placed in separate boxes. If you open one box and find a right-handed glove, you instantly know the other box contains the left-handed glove, even if the boxes are miles apart. That's similar to how entangled particles work. Another analogy is to imagine two coins spinning in perfect synchronization, always landing on the same side. No matter how far apart the coins are, their fates are intertwined. This synchronization represents the shared fate of entangled particles. These analogies are not perfect, but they provide a glimpse into the strange and counterintuitive world of quantum entanglement. Quantum computers, harnessing entanglement for exponential power. Entanglement is not just a scientific curiosity, it's the key to unlocking a new era of computing, quantum computing. Quantum computers exploit the principles of superposition and entanglement to perform calculations that are impossible for even the most powerful classical computers. Unlike classical computers, which store information as bits, zeros or ones, quantum computers use qubits. Qubits can exist in a superposition of states, meaning they can be 0, 1 or both simultaneously. This allows quantum computers to perform multiple calculations at once, exponentially increasing their processing power. Entanglement comes into play by linking qubits together. This linkage allows quantum computers to perform complex calculations and solve problems that are intractable for classical computers, such as breaking encryption codes, simulating molecules, and designing new materials. Beyond the horizon entanglement and the future of technology. The potential applications of entanglement extend far beyond quantum computing. This bizarre phenomenon has the potential to revolutionize various fields, from medicine to telecommunications. Quantum cryptography promises ultra-secure communication channels by exploiting the principles of entanglement. Since any attempt to eavesdrop on an entangled system would disturb its state, quantum cryptography ensures that any interception would be immediately detectable. Entanglement also holds promise for medical imaging and diagnostics. Researchers are exploring the use of entangled photons to create higher-resolution images of the human body, potentially leading to earlier and more accurate diagnoses. As we delve deeper into the mysteries of entanglement, we can expect even more groundbreaking applications to emerge, transforming our technological landscape in ways we can only begin to imagine. The universe interconnected. Entanglement's implications for reality. Beyond its technological potential, entanglement has profound implications for our understanding of the universe and our place within it. It forces us to rethink the very fabric of reality and the connections that bind everything together. It challenges our classical intuitions about space, time, and the nature of reality itself. The traditional boundaries we once believed in are now blurred, opening up new realms of possibilities. The fact that entangled particles can influence each other instantaneously, regardless of distance, suggests a deep interconnectedness within the universe. This phenomenon defies the speed limit set by the theory of relativity. It hints at the possibility that the universe is not a collection of separate objects, but rather a vast interconnected web of relationships. Every particle, every atom, may be part of a larger, unified whole. Entanglement also raises questions about the nature of time. If particles can interact instantaneously, what does this mean for our linear perception of past, present, and future? If information can be transmitted instantaneously between entangled particles, does this imply a breakdown of our classical understanding of cause and effect? Could this lead to new ways of thinking about communication and information transfer? Could entanglement provide a glimpse into a realm beyond our everyday experience of space and time? It may offer insights into dimensions and realities that we have yet to comprehend. These are just some of the profound questions raised by the existence of entanglement. The more we study it, the more it challenges our understanding and pushes the boundaries of science. As we continue to explore this mysterious phenomenon, we may uncover even more startling insights into the nature of reality itself. The journey into the world of entanglement is just beginning, and its implications are bound to be revolutionary. A final thought: the deepening mystery of quantum entanglement. Quantum entanglement stands as one of the most profound mysteries in modern science. It challenges our classical intuitions and reveals a universe far stranger and more interconnected than we ever imagined. While we have made remarkable progress in understanding and harnessing this bizarre phenomenon, many questions remain unanswered. The study of entanglement is not merely an intellectual pursuit. It has the potential to revolutionize our technological landscape and deepen our understanding of the universe and our place within it. As we continue to probe the depths of this quantum enigma, we can expect even more astonishing discoveries that will reshape our view of reality itself.